So in this lesson, we're going to talk about complex numbers or imaginary numbers and the power of I. So imaginary numbers allow us to take the square root of a negative number. So allow us to take the square root of a negative number. So what this kind of looks like is we have kind of our quadratic up here where we can't find the zeros because we know that that has to touch that x-axis. And so if it's not touching, we can find zeros that don't cross the x-axis. So the square root of a negative one is I. It's the square root of a negative, just that negative symbol underneath. And when it comes out, it becomes that I. So if we were to take and square I, it would become a negative 1. So it's kind of like taking square root of negative 1, square root of negative 1, which gives us negative 1. So that's I squared. And then if we took I cubed, so square root of negative 1 times square root of negative 1 times square root of negative 1, we would get negative I. And then if we added one more and we multiplied, then we would end up with negative 1, which multiplies to get 1. So that's kind of showing you how we're getting our different values here when we take and do different things. So for our examples 1 and 2 down here, we're going to find the values of A and B so that the equation is true. So A is going to match up with the 2, and the imaginary pieces are going to match up. Okay. So let's see what that's going to look like. A equals 2, so no solving there. And BI is equal to negative 3I, and we can go ahead and divide by I there to get B alone, and it's going to equal negative 3. So A is going to match up with negative 2, and then, this whole thing is going to match up with that, and these are going to match up the imaginary parts. So real things get set equal, and imaginary things can only be set equal. So we're going to subtract 2, and A would be negative 4, and then here we're going to divide by I, get B minus 4 equals negative 10, and add 4. So B equals negative 6. All right, so down here, we're going to simplify some of these. So remember, the negative is going to come out and become an I. And then we have the square root of 36, which is a 6. And so we have an I, square root 36, and then we write the 6 in front of the I, and that's our final answer. So 75, we know that the negative comes out, and then we have this 75 we need to simplify, 25 times 3, and then 25 comes out to become a 5, and it goes in front of the I, and then the 3 stays home, and we are done. When it comes to adding, we first just need to simplify, and then we can see if we can add the radicals, because they have to be the same in order to add. So let's go ahead and simplify. So this is going to be I radical 45 plus I radical 20, and now we can simplify our 45, 9 and 5, and our 20, 4 and 5. So this becomes 3I radical 5 plus 2I radical 5, and since they both have the same radicans, we can combine these. Now we don't add the radicans. Don't add the radicans. We can only add their coefficients. So 3 and 2 makes 5I radical 5. So if you want to try number 4 on your own, go for it. If you need some guidance, I will be working through that one now. So first just pull those negatives out, they become i's. Then we're going to break down 98, 49 times 2. And then the 50 we can break down as 25 times 2. And then pull out the perfect squares, so 7i square root 2 minus 5i square root 2. And since they're both square root 2's, we can take the 7i minus the 5i to get 2i radical 2. So let's go ahead and simplify these here. So our goal is to see if we can get and divide that exponent by 4. So we can get a 1. And so this would be I to the 4th times I to the 2nd, because remember we add when we multiply the exponents. So this becomes a 1, I to the 4th, and then what is I squared right here? Negative 1. So we're taking 1 times negative 1, and so our answer is negative 1. So we're looking for, again, the 4. So here, multiple of 4. So that means it's 1. If it's a multiple of 4, it is 1. 75, let's see. Well, we need to get it a multiple of 4. Let's think about what would be a multiple of 4. The biggest multiple of 4 that would be just less than 75 would be 72. So multiple of 4. So 18 times 4 is 72. And then what's left would be I to the 3rd, because that would add to get that 75. So I know this being a multiple of 4 is going to be 1 times, and then I to the 3rd is negative I. And then we have 1 times negative I is negative I. So we break it down as much as we can and see, but we want multiples of 4. So we want to see as close as we can get to that multiple of 4 is going to be 26, which is 104. And then there's 2 left. So we want this to be small enough that we are either a 1, 2, or 3, so we can simplify that. So this is a 1 since it is a multiple of 4. And then we have I squared, which is negative 1. And when we multiply these, we get negative 1. So complex numbers, we can write them in this form. This is our real part, and this is our imaginary part. So we always write that real part first, then plus our imaginary parts. So this is what's called standard form for our complex numbers. So let's go ahead and add. We can only add the real things with the real things, and then the imaginary pieces get added together. So 3 and negative 5 makes negative 2, and 7i and 2i is going to add to get 9i. So it's kind of like combining like terms, right? Here we need to distribute, and then we can go ahead and add our real parts to get 9, and our imaginary parts to get negative 10i. So again, real goes first, then plus or minus your imaginary part. When we multiply, we're going to take out the I, then we'll multiply the coefficients and radicans, and then we'll simplify. So let's take out our I. Now let's go ahead and multiply all of our pieces here. So I times I is I squared, and then 6 and 3 is 18. I squared, we know, is negative 1. And then we can break down our 18 as 9 times 2. And so we wind up with negative 1 times 3 radical 2, or negative 3 radical 2. So pull out the i's. Multiply the i's, multiply the radicals. Simplify the I squared to negative 1, and then the 98, 49, and 2. So the 7 comes out, and the 2 stays home, and we multiply to get negative 7 radical 2. On this next one, we're going to take and write it twice. Square root 11, negative 11, times square root negative 11. There we go. And now we're going to pull the i's out and multiply I squared, and then radical 121, which we know is 11, and this is negative 1, so negative 11. Go ahead and try number 4 on your own, and check when you're ready. And hopefully you got negative 3. So in the back here, we're going to multiply. So we're going to distribute. So we're going to get a 10i plus a 15i squared. I times I is I squared. And we're going to change that I squared because we know that I squared is negative 1. And that gives me 10i minus 15. But we need to write that in standard form. So that's not in standard form. Sad. So we need to make it negative 15 plus 10i. We want the real first, then the imaginary part. So here we're going to FOIL. You can do the foiling or you can do the box, whatever your heart desires. And let's go ahead and see what we get. Negative 12 plus 15i plus 8i minus 10i squared. Let's change that I squared to negative 1 and combine our middle terms. And then lastly, combine our real pieces there to get negative 2 plus 23i. And we want to FOIL this one. Remember, we do not distribute, so this is not equal to 16 plus 9i squared. No, no, no. We have 2 of them, so we need to FOIL. Go ahead and try FOILing that. And we get 16 and then 12i and then 12i and then 9i squared, changing the I squared to a negative 1 and combining your middle terms there, and then combining your 16 and negative 9, because this is 9 times negative 1, and then we get 7 plus 24i. Go ahead and try that last one. Again, make sure you write it out twice, and then you do your FOILing. We do not distribute over addition or subtraction. We have it twice, so we need to FOIL. So I went ahead and FOILed, and then I combined my 2 middle terms that are both just i's, and then I brought down my I squared as a negative 1, and so that gives me negative 4, and I'm going to go ahead and add that to my 25 because those are both real to give me 21 minus 20i.